to do that, we're going to do trig graphs, and then we're going to find out that sine 90, because 50 plus 40 is 90 degrees, right?
Yeah.
The sine 90 is always 1. Okay, but we'll get this over. Don't want that. It's not great that I know it wrong, but anyway, but we'll still rusty. Okay, the rest is all fine, I'm guessing. So guys, the way that they set these questions up was so that you could see some things. It's almost like they looked at common errors, common misconceptions, and they just highlighted them. So if we're looking at the first question, right, sine of 50 plus 40 is not the same as sine of 50 plus sine of 40. Do we recognize that when we're looking at E and F? When we are comparing those answers, right? Lots of people think that sine is almost like an X that you can just multiply into a bracket. Okay, but that's not actually the case. So sine of 90 is not the same as sine 50 plus sine 40. Okay. So that's what they were actually trying to do here. Similarly, if we're looking at G and H, sine of 2 times 35 is not the same as 2 sine 35. All right, so they're showing that you can't like take out a 2 from this bracket and put it in front. Okay, that's what they were trying to show. And the same thing here, you can't say that cos of 78 over 2 is the same as cos 78 over 2. So like the cos is not like a separate thing that you can just like multiply into a bracket. Okay, that's what they were showing there. Tan squared 60, guys, for this one you had to type in tan 60 and then square it. Remember there isn't a button for tan squared on the calculator. And then for sine squared 20 plus cos squared 20, that is equal to 1. That is actually an identity that we're going to work with next year. That sine squared of an angle plus cos squared of that same angle is actually always 1. Okay, that's it. Not able to click on the answer. Yeah. Are there any questions on that first one? Then guys, you also have to do, let me just check my thing here. 5.4, number 1i to n. Okay, so 5.4, and those are questions where you have to solve for theta. Okay, using the shift sign, shift cos, shift tan. Okay, I don't know if you remember how to do that. So I haven't finished copying down all of them yet onto this thing. So I'll just show you the first few, and then maybe we can just practice a couple if you didn't finish them. Remember, it was like a big rush at the end of last term. I don't know if people actually did work over the holidays. So that was the first. Yeah, I've just finished the first 2 there, and I was busy doing the third one, so I'll do that one with you. So for 1i, the instruction guys are saying use your calculator and solve for theta. They are saying correct to 1 decimal place. So you'll see that my answers are rounded to 1 decimal place. With the restriction that theta is between 0 and 90 degrees, okay, we will get that in all of these answers. No, that's considered just an angle, so it's almost like you throw an X, it's like a variable. So that's for these questions. Remember from last term, I said that what you are wanting is you are wanting to get your trig ratio and the angle on its own, right? Even if that angle is complicated, like in this case, the angle is theta minus 30 degrees. Okay, so what you need to do first is you need to move that 4 over. It's 1 on the other side. On this side, we're multiplying by 4, so we then have to divide by 4. All right, so that's a quarter. I know we can all do that. Then to get rid of that tan, we need to do shift tan. Okay, write that in if you've forgotten that. So here, what I did to get this answer, I did shift tan, and then that value, right? A bracket will also come up automatically when you type that in. So then you don't actually have to close the bracket on the calculator, but you can obviously. And that is the same as, this is what will actually show on the calculator, tan to the -1 over quarter. And I think we might have written that down last time in our calculation. You're more than welcome to do that. Okay, but when you then calculate that, you get 14,04. I think there were more decimals as well, I'm not sure now.
Yeah.
Yes. Thank you. Now, guys, the important thing here when it comes to rounding, it's going to come up more and more, especially when we're doing things like finance later on in the year. If they say you need to round to one decimal place, that's only your final answer that you round. Okay, you're not going to round every single calculation in your working to one decimal place. You're supposed to work with your unrounded answer in the calculator. You can just keep that answer in the calculator and work with it the whole time. So what I mean by that is, if I just show you here, if you do shift tan of a quarter, right? You're getting that 14,03. Now I know I did write 14,04. Okay, you can write down a value that's rounded, but technically you still need to be working with this value. So if, for example, it was 2 theta, right? And I now needed to divide by 2. You need to divide that same answer. Okay, you just work on the calculator, it uses the answer automatically by 2, and then only this value to I actually round to one decimal. Okay, so we're going to talk about it a lot still going forward, but you need to work with the accurate answer, unrounded answer, all the way through. Only in your final answer do you actually round properly to one decimal. Okay, so if you haven't been doing that, then just take into that going forward. For J, again, we want to get our sine theta minus 10 degrees on its own. So we want to get to that on its own. We need to get rid of everything else. So you could have done this all just in one step if you wanted to. But in 2 steps, you could multiply by 3 and then divide by 2. That's how I got to that value. Now you're going to do shift sine. That's going to give you theta minus 10. Again, I wrote this rounded to 2 decimals, but it did have more decimals, so I'm still working on my calculator. I'm not clearing it. And then you would have to add 10 digits. Any questions so far, guys? All right, okay, I am going to give you some time just to practice a few of them now on your own. Yes?
I put 0.153. Japan.
Shift sine. Okay, now for the next one, guys. It's 4 cos 2 theta. So now the whole angle is 2 theta, right? So I want to get cos 2 theta on its own. To do that, I need to get rid of the 4 that's in front. So I'm going to say 3.5 divided by 4, and that gives me that answer. Now, guys, it actually comes up as a fraction, I think 7/8, which you are obviously also more than welcome to work with. It's the same thing, 7/8, 0.875. It doesn't matter. To get 2 theta, you're going to do shift cos of that value, all right, 0.875 or 7/8, however you want to work with it. And you're getting this answer. All right, so guys, that is 2 theta. So now you can write 28.96, okay, if you want to. But also, if you're worried that you might forget that you're not supposed to round, it's maybe a good idea to, it's maybe a good idea to do this, to say 28.955 with a dot, dot, dot. Okay, to show that you're actually not rounding yet. Okay, so that's maybe a good idea just to remind yourself you are supposed to work with this answer. Because you're not going to have to type this answer in again. This calculator is very clever. It stores the answer if you just use the answer button. Or if you just press divided by 2, it uses the answer that was there. Okay, now this is the value that we need to round to one decimal. Okay, only your final answer, the value that you're actually getting for theta. So theta is now that divided by 2, which is 14.5 degrees. Okay, I'll write down L for you and you can do it on your own quickly. But L, we were supposed to do it. That's how it is. So I won't shout at you today, okay? First maths lesson. We'll have some grace for each other. Thank you to you guys as well. Okay, you need to solve for theta there, please, guys. So first you need to get your tan 2 theta on its own by getting rid of that 2 at the bottom there. Then you're going to do shift tan, and then you're going to divide by 2. Okay, just do that quickly, please.
So when we do that on the slide, probably decimals will be in the two.
So you can write however many decimals you want, but you need to keep it in the calculator. That's the important thing. When you're doing your calculations, you're not allowed to wrong.
No, no, no.
Do we have an answer? Okay, I got 42.2 degrees.
What?
Yeah.
I got
I got
34.
I got the same math.
I got
Okay. Thank you.
I don't know.
Guys, just check this first time by 2 there in the first, okay? That makes the problem.
That is the problem.
You have tan 2 theta over 2. So here you're dividing by 2. When you move it across, you must times by 2. All right, that could explain things.
Yes.
Then you're going to do shift tan of this value. And guys, that you can also just use the answer button for, right? Let me just show you quickly. So if you have your 5,102 times 2, there we go, there's the answer. Okay, you can write that fraction or the decimal, which is what I wrote down. Now when you need to do shift tan, because it's not always going to be something with just like 3 decimals. Okay, it might be a whole bunch of decimals. You can just do shift tan, and then if because you want to use that answer that you just got, you can just press the answer button. Okay, and that will automatically use the unrounded answer that you just calculated. And then you get your value for 2 theta from that. Okay, so the answer button is really a valuable thing to work with. So then there, I just wrote the first 3 decimals and then put a dot, dot, dot. But guys, if you wanted to write 84,4 there, that's fine, but you can't work with 84,4 in the calculator. In this case, it would give you the same answer, but it won't always. Yeah. Yes. Mhm.
Like you say, and then you end up counting. How are they negative angles?
So we're gonna have to wait. I'm gonna have to answer that question when we get to the Cartesian plane. All right, but we are going to put trig on the Cartesian plane where we have negative angles. All right, if you're thinking of zeros here, and then if you're going backwards, then you're working negative. Okay, so we will get to that soon. All right, that is the next one, guys. M, just do that one quickly. I think you were supposed to go up until M. All right, so we'll just finish this together, and then you'll have to do the other exercise on your own from here. We need to get to working with triangles. All right, so that is M. Just do that one quickly. No, you just need to make sure that you are writing it correctly.
But the solution is not we still need to
Yeah, you're just gonna have a more complicated equation to solve. Yeah.
I can take.
Yes.
If we forget to put the deletion box to everything else other than the answer, then it's still good.
Yeah, they usually, I mean, obviously we prefer you to actually put it in everywhere, but not too fast, right? Especially if you're doing a dot thing. I'm seeing now, actually, I didn't put my degree. Okay, we have an answer. Sounds like it. There we go. Check 1.9. Yes.
I got 8
8.9. You're supposed to round to 2 days. One is to 1 decimal. Sorry.
You just said 2%.
No, I obviously missed one.
Since when?
Sorry for this whole exercise. Yeah, it usually is 2 decimal, but it's quite strange.
I apologize. Will they specify their test?
Yeah, and if they don't, then it's 2. But I suppose if they don't, then we can't really penalize you for saying, yeah. Okay, guys, that's the last one. Just do that one quickly, then we can move on. Oh dear. Wait, what is sec is the reciprocal of cos.
I want to say, wait, say.
It's in the next exercise.
Yeah, another one. I'm thinking that
Can't type in sec 29 because there's no sec button. There is no sec button, so you need to work with the reciprocal. Shift code. Nope. One over the What are you doing? The next one. Right.
What's the difference between shift codes and what is it?
Shift cos is just what the calculation has to do. Calculate an angle. But shift cos and sec are not the same. All right, are we done? Okay, let's take a look.
Yeah.
All right, guys, this was enough, please. This enough, please. Thank you. There was a third exercise that you were supposed to do. I'm not going to go through that one now. We will mark that tomorrow because I do want us to get to triangles. You should have written it down last term, but let's just double check. It's exercise 5.5 on page 113. And there were only 2 questions, if I'm not mistaken, 1A and 1J. So exercise 5.5, page 113, 1A and 1J. Guys, those are on reciprocal ratios, which you haven't practiced yet, so you're going to have to look back at your notes. Okay, and if you can't figure them out, we will mark them tomorrow, so don't stress. Okay, but I do want to move on to triangle stuff now. 1.5 and J.
Well,
Yes.
for the second exercise, must we show our working out within the
Well, that's one that we marked now.
now for the 5.5.
5.5. Doing in between working it might be a good idea. That's the reason. What are you going to say? Stretching arm research, has to have a present tomorrow at, I mean, not tomorrow, Friday, 9/27. And so she needs some models to pose with her. So I'm looking for, and I'm sorry this sounds dreadful, but this is what I've been after. I've got two boys and I need two white girls. The person is done. So in order to do that, because of the copy act, the copy act, you're not allowed to photograph public without your permission, and because you're minors without your parents' permission. So if you're prepared to be a model for that on Friday, it's going to take a few minutes and steal from your lesson here. Then you need to get the phone call today, and I need to get signed, and you need to get signed, and I need to get back before Friday. So is there anyone that needs to go prepared to do it? One, two. Okay, can you come to me at break time? Because the forms I haven't printed them yet, I've entered stuff. Okay, thank you. And then Friday, I will send you when we. So you'll sit in class, do normal lesson, then I'll come and steal it. No problem. Thank you. Okay, let's go. Solving right angle triangles finally. Thank you. That's very focus. Very good. Thank you. Solving right angle triangles. So now all of the tricks are kind of basics. What the ratios are, how to use them in the calculators. We are now actually going to apply those to right angle triangles. Okay, thank you. This is what we were talking about last term. I think I did just show you an example on the board. We haven't actually done any.
Is it like a new chapter?
Okay. Thank you. I'm going to have on make that a bit smaller. Should I correct that? I'll do the triangle with small. Sorry, now I'm just quickly drawing that for this. The frozen it. Okay, there's the picture. So I've just put in everything that's written there. I've just shown on the picture, so you can see that it's a right angle triangle. They told us that if is 90 degrees, HG is 20, and then angle H is 23. That is quite small, but we did write it there at the top angle. And they want us to calculate HG, which is the side of the triangle. Now guys, usually in a right angle triangle, if we need to find one of the sides, we would have been given the other two, right? And we would work with Pythagoras. Now in this case, we only have one side. Okay, we have two angles, which means that we can find the third angle if we want to, doing angle sum and triangle. But guys, if we only have one side, we can't use Pythagoras to find another side. Okay, we need two of the three sides to use Pythagoras. So now, and I did mention this last term, just very briefly, we are actually going to be able to use trig. All right, one of the three trig ratios we will be able to use to find the answer here. Let's just quickly write down what was that little almost like way of remembering the three ratios. Can anyone remember that? So, Toa. It is a good idea to just maybe write that down at the top of your exercises if you're not used to working with them yet. Just as a reminder, because you don't always have to think what is sine again, what cos again. Because what we're going to have to do now, guys, we're going to have to identify, are we going to use sine or cos or tan? Right? Sometimes you can use more than one, then you can choose, but often we'll only be able to use one of them. So what you need to say to yourself is, we have this angle, 23 degrees, okay? The side that we are trying to find, in relation to this angle, do we see that FG is the opposite side, right? So we're trying to find the opposite side. So guys, we're either going to have to work with sine or tan, because those two trig ratios use or have the opposite side in them. Okay, we need to find the opposite side. So we're either going to have to work with sine or tan. What is the side that we have? 20 is the hypotenuse. All right. So guys, I'm just going to write in here, we need the opposite side. We have the hypotenuse. I'm looking at the 23-degree angle. That's the one that we have. I'm looking for the side opposite the 23-degree angle, and I have the hypotenuse. Which trig ratio works with opposite and hypotenuse? Sine. All right. So we're going to say sine of 23 degrees is equal to opposite, which is FG, over hypotenuse, which is 20. So guys, you need to look at the triangle and you need to identify what information do you have. Okay, that is going to help you decide which trig ratio to use. How can I now make FG the subject? How can I get rid of that 20? I'm saying FG divided by 20. When I move it, I'm going to have to times by 20. So FG is going to be 20 times, you don't actually have to write that times, but you can if you want. 20 times sine 23. And now you just use the calculator to work that out. Okay, so 20 times sine 23. And guys, again, you can actually just say 20 sine 23. All right. You don't have to put that times there, but maybe it makes you feel more comfortable to put it there. Doesn't matter. And the answer is 7,81. And that's the length of FG. And they didn't tell us what the unit is here, so let's just say units. Guys, people actually use this in real life. We used to do like a little project thing in grade 10, almost like an investigation, like a class activity where we took the class out into main road and you had to measure like the angle, if you are looking at, for example, what can I use as an example? If I'm looking up at this beam, for example, right? If there's a way for me to actually measure the angle and measure like maybe the length from here to where I'm standing, right? And I have this angle and I have this length, then I can actually calculate the height of that beam using tree. Okay, so I'll see if I can actually find that thing if I can say it somewhere. There's quite a nice activity just to do. Yeah.
So you can use that as a way to find out. Very.
Yes, Table Mountain or the cable car thingy there at the top. Yeah. So people actually use tree for that kind of stuff. Yeah. So what we had here was we just had one side and we had an angle. Right? So I'm saying is I am putting something like under this beam and I'm standing here. I can easily measure that length, which would be this side, right? And then if I have a way of measuring this angle, so from me to like up to the point of that beam, which would be that angle, then I can use trig to calculate the height of the floor to that beam. Just as an example. Yes, that is the thing, guys. You can only use this in a right angle triangle. Up until grade 11, where I'm going to teach you a way to work with trig in non-right angle triangles, but that is next week. Okay. All right, guys, let's do some more.
Yeah, can you also work with angle?
Yeah, you can. We're going to do some examples of that. Okay, let's find angle G. That is the next question. How can I find angle G? Do I need to use any funny trick things? No, I'm the same triangle, hey? Let's do that. (180 minus 90 minus 23 degrees). Remember your reason, please, guys. Angle sum in triangle. What's that? 67. 67, yeah.
It's an angle from triangle.
Yes. Now, guys, here I'm actually just going to fill in the stuff that we are calculating, right? Because we might be able to use it later on. So FG, we got a 7,81, and this angle now is 67. All right, the last question for this diagram, they're asking us now to find FH. Now, guys, FH, we are now actually multiple ways in which you can find FH. All right, so let's talk about that. You will get the same answer in all cases or a very similar answer. If we again work with this 23 degree angle, sorry, degree angle, Jesus, that they gave us, yeah. This 23 degree angle that they gave us, what is FH now in relation to that angle? It is now the adjacent side. You guys remember that word, adjacent? Okay, so we can fill that in there. This is the adjacent side. And we have the hypotenuse, right? That's also something that was given. So which trig correction works with adjacent and hypotenuse? Cos. So we can say cos of 23 degrees is equal to FH over 20. And again, I'm going to say that's one way of doing it. All right, we're going to talk about some other options now. So if we want to get FH on its own again, I need to again multiply the cos 23 by 20 and type that into the calculator and solve. So FH is equal to 20 cos 23, or you can put that time symbol there if you want. 20 cos 23 is equal to 18,41 units, yes. Yes. Not for true, no. Yeah, it's just like a rule, a definition. Right, what else could we do to find FH? Pythag, good, all right, because we have the other two sides, so we can find that one using Pythag. Let's do that quickly. I'll just write it next to this calculation. So FH squared is going to be equal to the hypotenuse squared, 20 squared. Yes. Minus, what's that, 7,81 squared. So guys, please note that 7,81 was rounded off. All right, it wasn't exactly 7,81, we rounded it off. So because we're now working with a rounded off value here, our final answer might differ slightly from 18,41. Okay, the decimals might be a little bit different, but that's okay. What do we have to write down though if we're using Pythagoras? Pythagoras. You have to put your reason for this one. Okay, so if you're not a fan of reasons, then the trig way would be quicker. Okay, so calculating this, let's just see what I get. 20 squared minus 7,81 squared. And this is a step that you don't need to write down, right? But I'm getting that 0,039. That's the whole value. And then you need to square root it. So FH is then, okay, it does actually come to the same answer, but the follow-up decimals are slightly different. Okay, the first two decimals are the same. Yes,
You also work outside different
figuration. Yes,
like 6 or 7.
absolutely. Yes, I'll write down a couple of those now. That will be part of the Pythag option. Right, you've done it now for a while already. Now, you also could have worked with the 23-degree angle and your opposite side that you've now calculated, right? If you wanted to. So if we're saying 23, okay, we have the opposite side, 7,81. I want to find the adjacent side. Which trig ratio works with opposite and adjacent? Opposite, adjacent, that's tan, okay? So we could say tan 23 is 7,81 over FH. Let's write that down quickly because this calculation is a little bit more complicated. Tan 23 is opposite, which we calculated in A was 7,81 over, let me just straighten that, over FH. Now guys, the actual making FH the subject now is not as straightforward in, for example, or as in the top one, because now the FH is at the bottom. All right, so I first need to multiply the other side by FH and then divide by tan 23. Yeah, you can do that all in one step if you want to. I'll just write it out properly. So we're going to say FH tan 23 degrees is then equal to 7,81. So then to get FH on its own, I will have to say 7,81 all over 23. But guys, you can go straight from this line to this line, okay? If you want to, you can just do that in your head. So let's see what that is. 7,81 over tan 23. Now this answer is slightly different, guys. Now I'm actually getting 18,40 units. And the reason for that is because I'm working with a rounded value. 7,81 is a value that I rounded off in. Okay, but it's fine. All of those answers will be on the memo, so it's okay. I'm just going to show you one last option, okay? You also could have worked with the 67-degree angle here, because we did calculate it. So you can say, for example, we're trying to find FH. You can say, okay, from the 67-degree angle, FH is opposite, and then you can use hypotenuse, or you can use adjacent. All right, it's up to you. So let's do opposite over hypotenuse. Is that fine? Sine. You can say sine 67 is equal to FH over 20. Opposite over hypotenuse. Sine 67 is equal to FH over 20. So again, to get FH on its own, I just need to multiply by 20. And guys, obviously you're not going to have to do multiple answers or multiple methods. I'm just showing you that there are multiple methods. So there isn't one method that's better than the other. It's basically just whatever you see thank you first, you can do. Okay, and this again is giving me 18,41. Huh? Yes, because for this other one we used a value that was wrong. Where here I've used specific values that were good. Okay, guys, I quickly want to show you how to find an angle if they haven't given you any angles, only that 90-degree angle. All right, so are you fine with this example? Just make sure that you've copied all of that down quickly. Yes, and compare or combine it with the stuff that we're doing now. Okay, so example 2, guys, you can just make the 2 so long. Get my space and sort of here. Yeah, I know. Wait. That down. In triangle ABC, angle B is 90 degrees. Small a is 36,5 centimeters. And small c is 11,9 centimeters. Find angle A. Okay, now guys, also in the past, if we were asked to find an angle in a triangle, usually we had the other two, right? Or we could use like exterior angle in a triangle or angle in a straight line, some kind of thing. But they would have given us more information, more angles than just one 90-degree angle. Okay, now we have no other angles. We just have a 90-degree angle there. But they have given us two sides, and obviously we can find the third side using pi tag if we want to do that. Okay. So I want you just to make a little dot in that angle. That is the angle that they're asking us to find. Now, guys, if you can't use your traditional methods of just like angles on a triangle or whatever, you need to start thinking about using trig. Okay, it's going to be a bit of a mind shift, something new that you need to look out for. So let's take a look. What are the sides that we have? Which sides do we have in relation to this angle? They have given us the opposite side. They have also given us the adjacent side. Which trig ratio works with opposite and adjacent? Tan. So tan of angle A is equal to opposite over adjacent, 36,5 over 11,9. And guys, what did we just practice? Yeah, how do we now get A on its own? If it's tan A, I need to do just tan of that fraction. All right. So angle A, it's as simple as that, guys. Angle A is tan to the -1 of this whole fraction, which you can simplify if you want to, but you can also just type it in just like that. Also what it will simplify to. And guys, you also don't have to show this step, but maybe just write it down now for this example. So you're going to type in shift tan, you're going to put in that fraction, You're gonna press equals and you're gonna get an answer of 71,943 degrees. And that is the answer. Okay, so if you have any two sides in a right angle triangle, you can find the other two angles using grid. Now, if they ask us to find angle C, we can do angles on a triangle now, all right, because we have 90 and we have that angle. Or you could use tan from this side. So if they ask us to find angle C, you could say, okay, tan of C is that opposite over this adjacent. All right, and then we can work out what that angle is. Are there any questions, guys? Okay, I'm going to give you a few of these to practice on your own, not me. It is in two different exercises, but I'll just give you one from each. So it is exercise 5.6 on page 116. I would like you to remember. Two. I'll just do number 2, and then exercise 5.7. Just number 2C. All right, guys, get going on that now. You also still have to do that exercise 5.5, please. Don't forget those two questions on the reciprocal ratio. And then these ones.
So we will be getting our graph.